parameters of soil which are important for vegetative growth. Particularly, two things are important for us. One is that germination of the seed. The first of all, most important thing is that the seed is able to germinate in the soil. That means it will have sufficient amount of air in the soil, water, temperature, and other nutrients that would make it to germinate. The seed would germinate first. Once the seed germinates, the next thing is the growth of the plant and stabilization of the plant in the soil medium. So we were discussing about what are the parameters that actually influence this. The total soil growth, total plant growth in the soil. Now we have discussed a number of parameters. We have in the course of last two classes, another very important parameter which is basically a part of which we have already discussed, because soil acidity would be a combined effect. Soil acidity or soil alkalinity is a combined effect of the vegetative total organic matter in the soil, total salt present in the soil, the different the characteristics of the soil structure, all this combined together to form soil acidity or soil alkalinity. But there's the combined effect is very important for us, because this would deal with this would be an important parameter for the seed germination and plant growth. So here, having to say that this, what we generally observe is, we generally start with soil say acidity. Just to say this is also would mean will include soil alkalinity. So here itself we just can say this. So the mostly, so here when we are discussing about this soil acidity, is the important part is that it also includes soil alkalinity. I mean, we say, just to mention that the soil acidity also includes soil alkalinity. Now generally, as you know, generally a soil left unattended for years will progressively change towards almost neutral acidity or alkalinity, right? Towards neutral acidity is says. So you can find out if the soil is unhindered or the soil is not disturbed for a long time, you will generally observe the soil pH would be between 6.1 to 7.2, about this. So you can see it is neither very acidic nor very alkaline. So this is what the soil would progressively move towards. In effect, generally at this range of pH, the soil microorganisms will deal with them also. At this range of pH, soil microorganisms find it convenient to reside in soil. We will also see this. We will try to observe this. How actually this thing is related. Acid soil generally in a starch. So here with the another important thing is related to this. Is a standard if soil shows pH like 3.4 to say about 4.5, which is quite acidic. The soil is treated with lime, to stabilize the pH, and experiments show that a disturbed soil with high acidity regenerates within 6 to 7 years after proper lime addition. So here, you try to see now is generally say lime addition. See this, effect of soil acidity. So we will just see, this is just to show, the effect of say how we can bring down. This is just to suggest. See, lime is a very important element. Lime is a very important compound that are used for different, kind of environmental remediation, as we have studied, in the case of water. Also in the case of soil, lime is a very important material to use. Any kind of soil reclamation problems, it generally starts with the lime addition. Okay, so if you do not know much about the soil, and if you have seen the soil conditions, not very good, you find it somewhat acidic or being run by some acidic water or things like that, the first thing one should try to do is to add lime, so that the soil becomes somewhat stabilized. And this is what, this is just to suggest that is what I meant is, there are many other materials that are generally also used, but the lime is one to start with. So okay, so if you could not write down that, we can still take it down. If a soil shows pH like 3.4 to 4.5, the soil is treated with lime to stabilize the pH, and experiments show that a disturbed soil with high acidity regenerates within 6 to 7 years after proper lime addition. This is quantity of the lime has to be found out. That is what I mean by proper lime addition. You must provide adequate amount of lime to regenerate the soil. Okay. Having said this, there is one important figure that we can draw on is, if you just see this, let us make a drawing of this. It would be clear to you now. You can see this. This is, this is about say pH, and we start about say about 4. We say 4, 4.5, say 4.5, 5, then 5.5, then 6.5, sorry, 6, 6.5, right, 6.5 and then 7. So you can find out 7.5, 8, then 0.5, 8.5, 8.5, then you say it is about 9, so 9, then 9.5, 9.5, and say 10. sense. So you can see we can graduate this, according to this 4, 4.5, 5.0, 5.5, 6.6, 6.5, 7. So this is the point where the soil is neutral. Okay, you can see this effect. Now 10, we just say go about till 10 here. Okay, 10, 7.5, 8, 8.5, 9, 9.5, 9.5 and 10. So this one is 9.5 and 10. Okay. Now having to see this, if you just try to see how all these organisms essentially stay in this. Say here it is the varieties of microorganisms and their activity. Varieties of microorganisms and their activity levels. Okay. So here you can see this. This is what varieties of microorganisms and their levels. Addition to that, with nutrient availability. We have discussed about the nutrient, soil nutrient, in the last class. What it means is that at different pH the nutrient availability in the soil changes. And then at different pH the nutrient availability in the soil changes. Say something like this. So let me explain this. Say here says for nitrogen. Nitrogen, if you just observe nitrogen in soil, nitrogen in soil would be about like this. This is what you can just observe nitrogen like this. This is 6 and then 6 to about 8. Nitrogen levels in soil would almost remain constant, but it would go down, as you can see that here as such. If you just make this as 10, if you just bring it down to 10 like this, right, here you can see that at 10 the nitrogen would be lowest again. What it means is, you can see this from this plot here, that the nitrogen would go down in the soil if the soil pH reduces further from 6. The soil nitrogen reduces. On the other hand, from the other side, if you see, for more than 8, starting from say 8.5, say at 8.5 it would begin to go down. So what is happening, if you are a reclamation engineer, suppose you are in the work of environmental remediation in the field, so you should attempt to have the soil pH to be remaining within 6 to 8. So this would be your objective. Only then you can supply sufficient nitrogen to the plant. So this is what this is about nitrogen. You just see this about, interestingly, for say there is another important aspect of this. If you can just see this, this is for phosphorus. Phosphorus seems to be somewhat more sensitive. And it can only remain at high level between 6.5 and 7.5, and then it would go down. It generally observes, it shows a plot like this. Whereby say about 8.5, it shows like this. Say from again from say 8.5 onwards, say about from here, you just make a correction here, say 8.5, this one is 8.5, okay, 8.5, I think I made a mistake somewhere. Anyway, the plot is like this. So here itself we can see this. So you can see this, the idea of this is at low pH, phosphorus suddenly going out of the soil, So the ideal condition for this, you can see this ideal situation for nitrogen is this, where the nitrogen should be kept. See here itself it says for phosphorus, this is phosphorus, you should try to keep about this much, because try to understand, it is not important that only phosphorus would do. So while you are trying to keep phosphorus, you should also try to keep nitrogen. The soil should not be unnecessarily enriched with phosphorus. So we should not try to keep we should not try to make the value of phosphorus high in the soil. So this is the ideal value at which you should work on, if we just want to keep, say there comes substances like this. So here again, if this is the value for the phosphorus generally is remain almost unaffected till about 6. This is potassium and sulfur. This is phosphorus, potassium and sulfur. Potassium and sulfur. This one is, as I have said, phosphorus. So here again, as you can see, we would be very safe if we can keep the pH between say 6 to 8. If we are pretty safe if we are keeping pH at 6 to 8. On the other hand, just try to see this, say this about potassium and sulfur. On the other hand, this calcium, if you just observe calcium at calcium shows a characteristics like this. Calcium and magnesium. So you can see this calcium and magnesium being here. Then we have iron, which is like this, the iron. This iron would be about okay. So iron is, now there are many other, manganese. Okay, let me draw the manganese one. The manganese stays like this, manganese is like this, whereas this one is okay. So this is manganese. There are a few more. I am not going into that, but you can see what is important here is there is another interesting thing to watch here is this one, that this is where a very important microorganism in the soil reside. So they are generally, these are the fungi. The fungi are generally, you can see their activity levels increase. Their activity level increase at lower pH, so about 5, but remain does not change much after between say 5 to are from 5 to 10. From 5 to 10, there the fungi do not change much. Secondly, here you can see this bacteria. So this bacteria, if you just observe here, another important aspect of bacteria is this. So bacteria and actinomycetes. And actinomycetes. So here, so this is where in most cases the soil, this is where the activity level. So this is where this is nutrient availability. For the plant to uptake, we generally call is an uptake, plant uptake. So this is where you can see now, if you just try to observe this, what is significant in this plot here is that this plot, if you just try to observe this is the level, this is the area we would generally like to keep the soil in. So if we are trying to remediate soil, this would be an area which is safe for us. So between, you can very well see this in, if we are between 6 to 8 pH, then we can consider that this is about the microorganismic activity. So here, so as you can see, this should be the level, as you can see here, this is the place that we have already been doing this. So here you can see that the difficult part, we would try to keep the potassium and sulfur at this pH. We would say mostly about this, whereas in the case of manganese, if you are just trying to keep this manganese like this, the iron remaining here. Okay, so here, as you can see, this particularly for the fungi and the bacteria, as you can see, this is the activity level where we would generally try to keep the fungi and bacteria. So here, if we just see this plot now, the best region is perhaps the 6 and 7. The best region is between 6 and 7. This is where we would try to keep, and this is to suggest, so here at 6 to 7, if we are trying to keep the soil, as a keep to serve the soil, then we are comfortable. This also suggests, this is clear to you. So you can see this is the area where you should try to keep the soil pH to remain to encourage the microorganismic activity and nutrient availability for the plants. So generally, as I have said, that the most crops also plants grow best at a pH between 6 and 7. There are, however, there are plants which show affinity for more acidic soil. But then again, that is, that is always possible, that is always the situation that we can think of. That is always the situation that we can think of. So, where there will be most crops are plants that we would generally try to keep is between 6 to 7. However, there are plants which show affinity for more acidic soil. Okay. Now, having gone from here, so if you just observe this now, there are few things that I would like to say. There are few things that I would just try to point out here is this soil microorganisms. You just see this soil microorganisms. Soil microorganisms are, as you can see now, these soil microorganisms that we have discussed. Soil microorganisms. Soil microorganisms. Which are the soil microorganisms? Say this very elementary description. I am not going to in large detail, but these are important for our case. This is bacteria. Bacteria is this singular cell. Singular cell organisms, which are either rod shaped, that is showing like this. This is how they would stay. This is how these bacteria look like. They would stay like this, rod shaped. Rod shaped. The width of these rods would be 1 micrometer wide and 3 micrometer long. 3 micrometer long. Okay. So this is this is 2 centimeter long. So another term I said actinomycetes. Characteristically, they are similar to bacteria. Characteristically, they are similar to bacteria. However, they look different. The cells form filaments. The cells form filaments. These are rod shaped. These are filament shaped. So the filament shaped is instead of having a rod, the rod being like this. This is about a rod kind of cylindrical rod structure that you see. Whereas this one would look like this. This one would be this one would be more looking like this, but this one also, this one would be, but if you just observe them, instead of a rod they would look like this. They would be more like filaments. Okay, these are the filaments quite similar to fungi. This is quite similar to, characteristically they are similar to bacteria. The cells form filaments which is also similar filaments similar to fungi. fungi are the cells of fungi, most fungi are joined to form filaments, which are 5 to 20 micrometer in diameter and can be from several centimeters to few meters in length. The cells of most fungi are joined to form filaments which are 5 to 20 micrometer in diameter and can be from several centimeters to few meters in length. This is fungi. You know, that's a typical fungi. You know, is all this. There are many kind of these mushrooms that you have seen. These mushrooms are essentially fungi. So apart from that, there are few more, you know, that I will just not. These are called, say, algae, that you know. Algae. This is the cells. Cells are about 10 to 40 micrometer in diameter. Then there are protozoas. Single celled animals feed on algae, fungi, etc. Feed on fungi, single celled animals feed on algae, fungi, etc. So why I have meant to say this, you know, why I have brought this in is critically important, because, you know, one is, you know, you can understand the food chain now. This is where the food chain starts. So, you know, if the food chain starts, means, you know, whenever in an environmental situation, in a situation when the environment is trying to regenerate itself, the first and foremost sign is that the food chain is becoming established. If you have seen, you know, say the reclaimed soil lands, so just next time you go to any mining field or any other areas where the soil has been reclaimed, the most important part is, you know, is to observe that when you think that, you know, the soil is inviting some larger animals, like, you know, if you find a snake in the soil, or if you find a fox in that area, or the soil, you find the foxes are moving around that area, you can be sure of that the soil is regenerating itself. So that is what is very important. So is for us to understand, to establish first, for a reclamation or say for an environmental engineer's point of view, the first and foremost thing is to observe that whether the food chain is becoming established or not. If you observe a certain food chain is becoming visible, a food chain is becoming visible, say smaller animals, smaller microorganisms feeding on the even smaller microorganisms and then going up in the food chain, we can very well say that the soil is coming back to its own potential. So that is absolutely important in terms of reclamation engineering. in terms of environmental engineering. The crux of environmental engineering remains with this, that whenever we are trying to do something, we must try to see that whether the natural system that used to exist or that still exists in some other areas can be replicated or can be brought back to this area again. If we are successful to a certain extent, we can consider that to be, the job of the reclamation engineer or a environmental engineering is successful. So that is the most important part. Apart from that, there are some soil fauna that we generally discuss of. I'll not go into that. The soil fauna, this typical, the soil fauna. Let me explain you here some of these things here. As you can observe here, a soil fauna here is this. It's a millipede that you can observe, that you can see in the soil, mostly very well visible. If you just take off any soil, you can think of these millipedes. This also is another example of that the soil is active. The soil is then you can say this peel millipedes. These are small millipedes that you can generally observe. You can see this is a common inhabitant of leaf litter, length 20 mm. They are generally about 20 mm in length. So this one is the rolled up millipede. The rolled up millipede is about 5 mm. These are the other insects. The insects and this the typical typical fauna that is generally observed. The millipedes and all this. Say this is, if you just observe this one particularly, you can see this is a woodlouse. That is, we generally, this area of Kharagpur is very famous of woodlouse. This is the termites, the family of the termites, woodlouse and the family of the termites. Then is you can see this, they are generally, scanning electron microscope. Under scanning electron microscope, you can see this, the formites, member of order. This one is length of about 0.15 mm, 0.15 mm diameter. These are moving around. So this can be under a standard this scanning electron microscope. This is how it looks like. So there are the springtails, the other kind of the soil microorganisms. This one is another, the very typical soil, the very typical one that you can see here also is something like the earthworm. The typical earthworm that we generally observe. It is another interesting thing. I mean, if you can think of, in our childhood, we used to see a lot of earthworms in the soil. Okay, see, you could very well see earthworms, in the soil, particularly during rainy season. You would see that the earthworms coming out. But whenever we have started to use pesticides, and whenever this kind of cultivation has come in, wherever there we have used a number of fertilizers and different kinds of pesticides, their numbers have gone down. So here again, these are the indicators in the soil. If a soil is good, you will find these earthworms are coming back. You will find that the earthworms are more existent there. Unusually, many people take a different view nowadays. They generally think these as nuisance. But these are the important part of soil. This, even without being an engineer, if you just try to can appreciate that the soil should have all these things, and our effort should be to see that, as a reclamation engineer or an environmental engineer, to bring back a condition where this kind of insects, this kind of microorganisms can live in the soil. Then our job is done. Then you are successful by all measures. So here it says the other things would follow. You will find plants growing, you will find grasses there, you will find larger insects, you will find snakes there, foxes there, the all kind of things would begin to move on. But unless you see them, you are never sure whether you have been actually successful or not. Okay. So here it says, this is what, I will not go into the discussion of this. I will not go into the discussion of this.
We can see most of them in rainy season.
Yeah.
Is that mean that The soil regenerates more in rainy season.
Well, one thing is this, most of this and this say earthworms and things like that, they generally remain at a say between say about up to 50 centimeter or 100 centimeter in the soil depth. Generally remain, they come out in the rainy season just because of their holes become filled up with water. Also there, I mean, some reproductive behavior also can bring them out. There is some kind of reproductive behavior. Well, I mean, one thing can be said, say about rainy season. Yes, you are to a certain extent right, because in most cases you will find that the rainy season is when the food is maximum available in the soil. If it is the food is maximum available, at about that time is the period when the reproductive cycle begins. The reproduction essentially begins at that time. So all kind of animals, insects, smaller microorganisms, they become more active during that time, because that is the season where they reproduce. Mostly they reproduce, many of them reproduce. So that is what one thing you will find, that their activities grow, and particularly in various other things like, so when the food is available, the reproduction basically deals with that. See, in our, even in human culture also, they say that after this paddy, the growth of paddy and all this, why the festivity is basically, it directly and indirectly points towards the good season for reproduction. That is how it has come into the human culture also. So this is what, this is why this you can see this, that these are mostly the organisms, the fauna that is available in the soil. So as a reclamation engineer, our objective is to see that these are the things, these things are protected. So here again, let me tell you another important thing here, that is to say, whenever the soil is disturbed due to dam construction, over tillage, mining activity, road making, the effort to bring back the soil, into its earlier form of productivity, the check and monitoring of the above soil parameters become important, and their quality improvement, and their quality improvement, the check and monitoring of the soil parameters become important. Their quality improvement can be observed with the establishment of food chain for the insects and larger animals like snakes, rats, foxes, in the reclaimed area. That is, reclaimed area is the area where you are working, where the soil has been disturbed due to some activity, mining, road construction, over tillage, or say dam construction or anything like that. The soil is damaged. The early sign that the soil, when you are working on the soil, to improve the quality of the soil, the early check that you can see is that whenever you are seeing that the establishment of food chain has started or it is maturing up, you observe that the establishment of food chain has been taking place in the reclaimed area. You can see that to be a sign of soil improvement, So here again, we would now next on, we will further carry on this thing too. This is the soil vegetative parameters. In the parameters for soil growth are complete. So we have already discussed almost all parameters that are necessary for soil growth. If you have this much idea about soil for establishment of the plant, germination of seeds and establishment of plants, you are surely good enough in dealing with most of the soil problems. Again on this, there is another important area that we should discuss is the soil erosion. Soil erosion deals with the large scale displacement of soil from the existing to a new area etc. The soil erosion deals with the large scale displacement of soil from the existing area to a new area or any other place, as in river, pond, etc. Okay. So if it is moving from one place to another, from one land surface to another land surface, that is also a erosion. if it is moving from one land surface to another medium, like in the water, in a pond, in rivers also, that is also soil erosion. We will deal with this after a 5 minutes break, right?